Hey everybody, it's Mr. Carr again. Today we're going to be looking at 2.2a. We're going to prove theorems about our perpendicular lines. To get an idea of what is important about our perpendicular lines, do a little drawing here. Draw a smiley face like this and a line directly underneath it. Okay, so if I want to find the shortest distance, this is an important part. The shortest distance is always going to be a perpendicular distance. So if I draw this down here, this would be my distance right here. It's a perpendicular distance like that. It is not this length or any of these other lengths here. Okay, there's only one that's going to be the shortest distance, and that's that perpendicular distance. Okay, so some other things with our perpendicular lines. If we have linear pairs of congruent angles, so if two lines intersect to form a pair of congruent angles, so basically it looks like this. Or sorry, no, no, it doesn't. It's got to be a pair of congruent angles. So if I know this is true, okay, then the lines are perpendicular. So the idea is that if I know this in my diagram, that my two angles match up like this, then the only thing that can be true from that is if I have perpendicular lines like that. Okay. So we're saying this implies this. Perpendicular lines and right angles. If two lines are perpendicular, then the intersection forms two right angles. So if I draw it like this, so I know two lines are perpendicular, then I know that no matter what, it's always going to be like that. So we get two right angles based on this. Okay. So if you just see one, then you know that two is going to be true. Okay. So I guess what I should do is do this. This implies this. Where we have it bothers me that's a little bit of space, so let me move it closer. There we go. All right. So that implies that we have two right angles now. Okay. So that is what we're working with today is our perpendicular lines. So we look at this diagram here. In this diagram, we know that angle 1 and angle 2 are congruent to each other. To explain why 2 and 3 are not supplementary. So in this scenario, if 1 and 2 are congruent, okay, that means that angle 1 and angle 2 have to be right angles. Okay. So that's our linear pair like this. A linear pair of congruent angles means they are going to be perpendicular. Well, now, logically, if these are right angles here and here, then I have to have right angles here and here. Well, that makes angle 3 less than 90 degrees. So since that, since angle 2 equals 90 degrees and angle 3 has to be less than 90 degrees, because that's the only way that 3 and 4 can make this right angle here in the corner here, then angle 2 and angle 3 cannot be supplementary. Okay. We would have to have an angle be exactly 90 degrees for it to be supplementary with angle 2 in this case. All right. Let me just write that last part a little bit better there. Supplementary. Okay. So try these a little bit on your own, but I'm going to go through them anyway, just to make sure. If C is perpendicular to D, so remember that's what that symbol means. It means is perpendicular to. What do you know about the sum of angles 3 and 4? So in this case, because the two lines are perpendicular, then that means these are both have to be right angles here. So that means the sum has to be 180. So writing it in complete sentences, but basically you should be able to get to this, that angle 3 plus angle 4 equals 180 degrees. Okay, determines which lines, if any, must be parallel. So this is a concept that we didn't quite cover, but it is a quick thing where if I have two lines that are perpendicular to the same line, those two lines have to be parallel. So what I mean by that is this. I look at X and Y. Notice that X is perpendicular to R, and so is Y. So this is yes, because X is perpendicular to R and Y is perpendicular to R. So if they are perpendicular to the same line, like this is perpendicular here, this one's here, then it's going to be parallel to each other. They have to be parallel then. Okay, so Y is Z. Okay, so Y and Z, well, I'm going to come back to that one. Let me go to X and Z because that's a little bit easier. X and Z are both perpendicular to S. So that's a yes. X is perpendicular to S and Z is perpendicular to S. Once again, they're perpendicular to the same line. They have to be parallel to each other. R and S, well, that is also going to be a yes because these are both perpendicular to X right here. So my reasoning is that R is perpendicular to X and S is perpendicular to X. So let me come back to Y and Z because they do not have it directly. Y is perpendicular here, Z is perpendicular here. But since Y is parallel to X and X is parallel to Z, that means the only way for that to work is if Y and Z are also parallel in this diagram. So my answer here is also a yes, and I would say it this way. So I would say that we were looking at Y and Z. So Y is parallel to X and X is parallel to Z. So Y is parallel to Z. That's the only way for that to work. All right. A couple more problems here. So 1 and 2 are congruent and supplementary, which of the following must be true. So to be congruent and supplementary, if ever I'm in doubt, we'll draw it out. So angle 1, angle 2, congruent and supplementary. That makes them both 90 degrees. So when I look at that, I've got this linear pair, which means that angle 1 and 2 are a linear pair. Angle 2 is a right angle. It is not going to be 45 degrees, but the supplementary means that they add up to 180, and it's not going to be 90 there. Okay. Find the value of X that makes these two lines perpendicular. So in this diagram, make it perpendicular. That means that X plus 8X minus 8X plus 9 has to equal to 90. And from there, you can combine 9X plus 9 equals 90. Subtract 9, so that 9X equals 81. Divide by 9, and I get X equals 9. And then this one, really straightforward. If this is a right angle, that means these are all right angles around it. So that means X minus 15 has to equal to 90. So I can add 15. So X comes out to 105 degrees there. Okay. And that is it for 2.2a. I did all these examples because we do our perpendicular lines in a variety of ways. Just want to see a little bit of everything there. All right. But that's it for today. Take care, everyone.